Science and technology is not killing UPSC aspirants because it is too vast. It is killing them because they are reading it without structure. They know AI, they know hydrogen, they know CRISPR, they know 6G. But UPSC is not asking whether you have heard these terms. UPSC is asking whether you understand the mechanism, the distinction, and the trap. And that is where most students fail. So today I am going to show you how to study science and technology not as random current affairs but as five systems of control. Once you understand these five systems, the subject becomes easier to revise, easier to eliminate, and much easier to control in exam hall. Welcome to Metis IAS. Let me say this very clearly. Science and technology is one of the most misunderstood subjects in UPSC prelims. Not because it is impossible, not because it is always too technical, not because questions come questions come from another planet. Students fear science and technology for one reason, because they are studying it in fragments. They read artificial intelligence separately. They read semiconductors separately. They read hydrogen separately. They read fusion separately. They read CRISPR separately. They read telecom separately. Everything is somewhere in the mind, but nothing is connected. And when UPSC gives you a statement based question with one technical twist, one incorrect relationship, and one hidden exaggeration, what happened? The student will collapse. Not because he never read it, but because he never structurally understood it. That is why today's class is important. Today I am not teaching science and technology as random current affairs. I am teaching it as a system, a structure, a map, a method of control. And once you understand this method, science and technology stops looking random. Then what? It starts looking predictable. It starts looking manageable. It starts looking scoreable. So, this is not a lecture on science and technology. This is a lecture on how to control science and technology for UPSC Prelims 2026. And I want you to listen to this very carefully. By the end of this class, I do not want you to merely know 5 or 6 topics. Then what? I want you to see the hidden architecture behind the subject. What? Hidden architecture behind the subject. Because once that architecture becomes visible to you, your revision changes, your elimination changes, and your confidence in the exam hall changes. So, now let us begin with diagnosis. What diagnosis? Why do students actually fail in science and technology? Most aspirants give the wrong answer. What? They say, Sir, I failed because I did not cover enough current affairs. Sir, I failed because science and technology is too vast. Sir, I failed because I forgot facts. But that is not the deepest truth here. The deeper truth is this: students often fail in science and technology not because they read too little. Then what? Then why? But because they understood too little. They not read too little, but what? They because what? They understood too little. That is why. So please understand the difference. Reading is not understanding. Exposure is not mastery. Mastery. Recognition is not precision. A student may have seen the word green hydrogen 10 times, but if UPSC asks where hydrogen is evolved during electrolysis, he or she may fail. A student may have heard about AI every week, but if UPSC frames a statement implying AI, but if UPSC frames a statement implying AI thinks exactly like humans, she or he may still fail. A student may know CRISPR means gene editing, but UPSC tests somatic versus germline. Ethical implications, or inherited effect. That same student may get trapped. So, what is the actual disease? Is superficial familiarity. Superficial familiarity. Students, what is superficial familiarity? I will explain here. Students know the headlines, but they do not know the mechanisms. They know vocabulary, but they do not know the structure. They know what is being discussed here, but they do not know what exactly UPS can twist here. And in prelims, that gap is deadly because the paper is increasingly rewarding precise conceptual control. Please underline these words: precise conceptual control. Precise conceptual control. Not broad excitement, not shallow awareness, not technical sounding confidence. It needs precise control. So, science and technology punish one thing very ruthlessly. What is that? That is shallow understanding. That is shallow understanding. Let me illustrate easily, then you can easily understand. Suppose two students read the same monthly current affairs PDF. One student marks everything important with a highlighter. The other student asks four questions like, what is it? How does it work? What is the trap here? And why does UPSC care this? So these four questions he asked for he asked himself, he or she. The second student is preparing for prelims. The first student is only collecting paper. Through highlighting everything as important. So here UPSC is not asking whether you know the name of the technology or not. It is asking whether you can detect where the statement goes wrong or right. That is the final implication for UPSC. That is what UPSC need here. So now we come to the central issue, that is, how does UPSC actually think while framing science and technology questions? How does UPSC think? This is where serious aspirants separate themselves from the crowd. How? Because the average student studies in the subject, the serious student studies the examiner mindset. Now, what is the pattern? UPSC is increasingly moving away from very crude factual testing. It is now more interested in precision. Precision. That means the examiner wants to know, can you distinguish close concepts? Can you detect wrong causation? Like detect wrong cause. Can you identify hidden exaggeration? Can you notice when a correct technical word is being used inside a wrong statement? Can you notice when a correct technical word is being used inside a wrong statement? This is extremely important because many wrong options today are not obviously foolish. They are intelligently wrong. They may contain one correct scientific word, one wrong relationship, one exaggerated capability, one hidden absolute term, or one false implication. They may contain all of these or one of these. That is why casual elimination is becoming dangerous. Earlier, some students survived with very broad instincts, like this sounds weird, so maybe wrong. That sounds too much, so maybe wrong. Now that is not enough here because the wrong options often sound elegant, scientific, modern, sophisticated, and that is precisely why students get trapped. So your mindset must change when you see an science when you see an science and technology statement. Do not get impressed. Then what here may do? Interrogate it. Ask what is being claimed. Is it definition claim, a process claim, a causation claim, a causation claim, a comparison claim, and an application claim? Ask. Then ask, where could distortion have entered here? What? Where could distortion have entered? That is exactly how real prelims elimination works now. UPSC does not reward students who are familiar with scientific terms. UPSC does not reward. It rewards students who remain precise when scientific terms are used to mislead them. This is the important time. AI uses data may be true. AI understands, artificial intelligence understands reality exactly like a human mind. May sound advanced, but the second statement is a conceptual jump. Let me take two statements. That is, AI uses data may be true. AI understands reality exactly like a human mind. May sound advanced, but the second statement is a conceptual jump. So UPSC lives in those gems. If you understand this one point alone, your science and technology preparation changes completely. You will stop asking like this: how many topics should I read, etc. And start asking, how exactly can UPSC start this topic? This is a much more powerful question. This is much more powerful question. Now let us solve the problem. How do we reduce confusion through systems? According to the Metis approach, most high value science and technology themes for UPSC can be organized into five major systems. What are they? That is System 1 Intelligence, System 2 Compute, System 3 Energy, System 4 Infrastructure, and final system, that is fifth system Biology. Now, why this framework powerful? Because the mind remembers structured clusters far better than scattered fragments. If I tell you to separately remember artificial intelligence, deepfakes, AI bias, AI regulation, misinformation, algorithm risk, etc., it feels like many topics. But the moment I tell you all these belong to the intelligence system, your mind gets a folder, and once a folder appears, memory stress reduces. Same with compute, chips, GPUs, CPUs, data centers, semiconductors, and high performance processing, etc. And same with energy, like hydrogen, electrolysis, fuel cells, fusion, battery logic, energy transition, etc. And same with infrastructure also, like 6G, high frequency, small cells, edge computing, Web3, and distributed architecture. And finally, same with biology also, like CRISPR, genomics, gene editing, somatic, germline, bioethics, etc. So now do you see what has happened here? The subject has stopped being a crowd of disconnected news items. It has become a mapped territory. So, and that changes everything. Revision becomes easier, retention becomes easier, recall becomes easier, and elimination becomes calmer. The student who studies topics feels overloaded. The student who studies systems feels in control. Please do not treat this framework as merely a teaching style. This is a revision method, a memory method, an elimination method, and an exam hall confidence method. So, now let us enter the first system, that is system number 1. intelligence. I want you to think beyond the word. What is that word? Do not reduce it to smart machine. The system is about control over perception, and perception is power. Before people act, they perceive. Before they vote, they perceive. Before they fear, they perceive. Before they trust, they perceive. Before they react, they perceive. So, if technology starts shaping perception at scale, it stops being just software. It becomes influence architecture. So, think about the digital world. Search systems influence what you see first. Recommend Recommendation systems influence what you spend time on. Generative systems influence what content can be produced quickly. Synthetic media influences what appears believable. That means intelligence technologies are no longer just doing tasks. They are shaping reality as experienced by citizens. And once that happens, governance enters. Because now the questions become, who controls these systems? How are they trained? What bias do they carry? Can they manipulate people? Can they destabilize public trust? Can they affect democratic life? This is exactly why UPSC cares. This is exactly why UPSC cares. AI is not just a gadget story, it is a society story, a governance story, a rights story, a power story. In the digital age, control over precision is a form of power. So let me illustrate, you can understand easily. Earlier, if you wanted to influence masses, what will you do? What you needed newspapers, radio, television, institutions. Now, algorithmic systems can shape attention flows at scale. This is a structural shift in civilization. UPSC likes topics where technology meets public consequence. So always ask, what does this technology do to society? Trust, governance, and power. Now let us define AI properly. AI means artificial intelligence. This is one of the most important corrections a UPSC aspirant must make. The safest and most exam useful way to understand artificial intelligence is this. AI is primarily a system of pattern recognition and pattern prediction. It studies data, it identifies relationships in data, it learns structures, probabilities, and associations. Then it generates output based on those learned patterns. Now, those outputs may be extremely impressive. AI can generate text, it can classify images, it can predict behavior, it can help in diagnosis, it can write code, it can simulate conversation. But none of this should push you into conceptual laziness. AI is not human consciousness. AI is not self awareness. AI is not human like understanding in the full philosophical sense. This distinction matters enormously. because students often make a mistake. They see fluent output and assume inner understanding. That is not safe thinking. A system can produce human like output without possessing human like consciousness. That is exactly why you must separate output similarity from inner equivalence. This is where prelims traps can emerge. You may feel this is boring, but actually it's not. This is most important for prelims. A statement may sound advanced, but if it casually treats AI as identical to human cognition, you must become alert in the statement in the preliminary examination. So traps are there, always there. AI may simulate human like output. That does not mean it possesses human like understanding. Please note this sentence. AI may simulate human like output. That does not mean it possesses human like understanding. Let me illustrate easily. You can understand. A calculator gives correct answer. That does not mean it understands mathematics the way a mathematician does. The same caution, the same caution at a much more advanced level applies to AI. Words like thinks, understands exactly, possesses consciousness, autonomous comprehensions like humans should trigger caution when when in the exam hall. When in the exam hall. Now let us move from nature to risk. What is the risk with AI? What are the risks associated with AI? Whenever UPSC studies a major technology, it also studies its consequences. That is what makes the paper serious. Now, what are the AI risks? Key AI risks. The first major one is deep fakes. What is deep fake? What is the definition of deep fake? Deep fakes are synthetic media outputs that imitate real people's voices, faces, or expressions convincingly. Deepfake are synthetic media outputs, deepfakes, that imitate real people's voices, faces, or expressions convincingly. That is deepfake. Then, why is that dangerous? Because public trust depends heavily on perceived evidence. What it means? If videos becomes unreliable, if voice becomes forgettable and forgeable, if image becomes infinitely manipulable manipulate, then truth itself becomes harder to verify. And once truth becomes unstable, may systems become vulnerable, like election systems, public trust systems, communal harmony, diplomatic communication, reputation, fraud prevention, like these. The second risk is misinformation at scale. Falsehood is not new, but scalable, believable falsehood is a new problem. The third risk is bias. If training data contains distortions, the model can reproduce or amplify those distortions. The fourth risk is opacity. Highly complex AI systems may produce outputs that are difficult to interpret transparently. The fifth risk is concentration of power. If advanced intelligence infrastructure is controlled by a small number of actors, then capability asymmetry grows. Now do not study these as a disconnected issues. Study them as one structural idea. AI increases capability, but is also increases the scale and speed of harm when if misused. AI increases capability, but it also increases the scale and speed of harm if misused. So, the danger of AI is not only that it automates work, it is that it can automate deception. So, let me illustrate. A fake rumor earlier needed time, people, and distribution. A deepfake today can create believable falsehood with much greater speed and scale. That changes the risk profile completely. Notice something. This is why science and technology is no longer a side subject, because one technology now affects society, truth, governance, rights, economy, and national security also. That is why UPSC cannot ignore it, and that is why you cannot prepare it casually. So now let us move to regulation. This is a classic UPSC conceptual area. Many students think AI is risky, so regulate all AI in the same way. That sounds responsible, but it is not intellectually mature, because all AI applications are not equally risky. A music recommendation system is not the same as an AI system used in medical decision making, biometric surveillance, critical infrastructure control, policing, or judicial support. Different domains create different consequences. So, regulation cannot be flat, it has to be risk based. That means governance must be proportionate to the use case, the potential harm, the rights involved, the scale of impact, and the social consequences of failure or misuse. This is exactly the kind of distinction UPSC likes. Now, another important point here is good regulation must balance safety and innovation. If regulation is too weak, what will happen? Harm expands. If regulation is too rigid, innovation slows or gets suffocated. So the question is not regulated or not regulate. Regulate or not regulate. The question is how to regulate intelligently. That is much more serious policy question here. The best regulation is not panic regulation. Then what? It is proportionate regulation. Let me take one statement. Different AI applications may pose different levels of risk. Statement number two. Therefore, all AI systems should be governed identically. In these two, in these two statements, the first may be true. The second is where the trap enters, not identically. So you have to prepare, understand, identify these traps in UPSC CSE preliminary examination as far as S&T is concerned. Uniform regulation is a trap. So this is the first system. Now let us move to system number 2, that is compute. If intelligence is the visible face, compute is the engine underneath it. Many students become fascinated by what technology does, but fewer ask what material capacity makes this possible. That is where compute comes in. No large AI system works without compute. No high-end simulation works without compute. No serious digital ecosystem scales without compute. So compute is not just an engineering detail. It is strategic capacity. It determines how much processing power can be brought to bear on a problem. And in the AI era, this matters enormously because now states and companies are not only competing in algorithms, they are competing in compute access. Like what? That is why chips matter. That is why semiconductors matter. Why? That is why high performance hardware matters. That is why data centers matter. Technology power is not floating in the air, it sits on hardware. And that hardware is political, industrial, economic, and strategic. In the AI age, power does not come only from code, it also comes from compute. Let me illustrate with simple statement. A brilliant software model without serious compute is like a high level plan without machinery. The design may exist, but large execution becomes impossible. So you have to understand very much clear about compute. Now let us understand compute architecture, that is CPU versus CPU. This looks basic, but do not underestimate it. UPSC can very easily test this indirectly. CPU means what? Central processing unit. GPU means ja- graphics, graphics processing unit. Now the key difference lies in architecture. A CPU is built for strong general purpose processing and controlled execution across various tasks. Then comes to GPU. GPU is built to handle very large numbers of similar operations simultaneously. This is the heart of the distinction: sequential versus parallel strength. Sequential for CPU, parallel strength for GPU. Sequential means one by one, then parallel means thousands together. Now, why does this matter for AI? Because many AI workloads, especially deep learning tasks, involve huge numbers of repeated mathematical operations. At the scale, parallelism becomes enormously useful. That is why GPUs became central to AI progress. Not because GPUs are smarter, but because their architecture matches the workload. This is an important pattern in technology. Success often emerges when the nature of the task and the design of tool align. So, in that way, in that lines, the GPU did not become important because of hype. It became important because architecture met demand. Let me illustrate easily. If one teacher checks one paper at a time, that is one style of work. If thousands of similar micro tasks are distributed simultaneously across many workers, that is another style. The second intuition resembles why parallel systems matter here. So let me take one statement. Please avoid conclusions like GPU is always better than CPU. Please avoid these type of conclusions. The better statement is for many heavily parallel AI workloads, GPA architecture is especially useful. That is why they are using GPU architecture. Simple. Nothing more than that. Now let us go into the deeper into why GPU importance has exploded. Because AI today is a scale problem. Small models are one thing, large advanced models are another thing entirely. So, as model size increases, parameter size grows, data demand grows, training completely grows, training complexity grows, energy demand grows, and computational burden rises sharply. At that point, compute stops being a background issue. It becomes destiny. This is why access to advanced chips matters. This is why high performance computing matters. This is why semiconductor ecosystems matter. Now, things like a UPSC student, if advanced compute is concentrated in a small number of places, then technological leadership also becomes concentrated here or there at one place. This affects what? Innovation, economic power, strategic autonomy, scientific competitiveness, and even military technology capability also affect. So chips are not just electronics, they are geopolitical assets. In the century of AI, compute inequality may become a major form of power inequality. Please remember this sentence all the time. When you read about semiconductors, do not stop at manufacturing. Ask what does this mean for capability concentration? Now let us bring this into the Indian context. Why do data and compute matter for India? Because India is not a small digital market. India is becoming a large digital civilization through what? Payments, identity systems, digital governance, platforms, public infrastructure, expanding AI systems. Now, in such a country, data is not just an economic resource, it is also a strategic resource. It reflects many things like behavior, transactions, movement, consumption, service usage, and institutional interaction also. This is why data sovereignty matters. At a broad level, it means control and governance of data in a way that protects national legal authority, strategic autonomy, and long term public interest. At a broader level, what it means? Data sovereignty means it means control and governance of data in a way that protects national legal authority, strategic autonomy, and long term public interest. If critical digital layers are extremely vulnerable or excessively dependent, sovereignty becomes thinner. That is why digital autonomy matters. That is why cyber security matters. That is why strategic compute capacity matters. That is why infrastructure resilience matters. UPSC may ask this directly or indirectly. The wording may differ, but the concept is central. In the 21st century, sovereignty is not only territorial, it is also digital. Let me take few statements to illustrate. A country that depends on outside energy is strategically constrained in one way. A country that depends on outside control over critical digital layers may be constrained in another way. Both are the sovereignty issues here, either energy or digital layers. Now we move to system number 3, that is energy. This is one of the deepest systems because civilization itself runs on energy. Industry runs on energy, transport runs on energy, urban systems runs on energy, digital infrastructure also runs on energy. Strategic resilience runs on energy. So energy is not merely a fuel chapter here, it is a civilizational operating system. That is why UPSC repeatedly returns to energy linked themes. Because these are not just science questions, they are also questions of economy, climate, technology, security, and development. Now the world is going through an energy transition. That means societies are trying to redesign how energy is produced, stored, transported, and used. And every pathway brings trade-offs like cost, cleanliness, cost, scalability, safety, infrastructure compatibility, resource dependence, etc. That is why topics like green hydrogen and fusion become important. They are not just technological ideas, they are possible answers to large energy system problems here. Energy is not just what runs a machine, it is what runs a national developmental capacity. Whenever you study a new energy technology, whenever you study a new energy technology, ask yourself, what energy system problems is this trying to solve? That question immediately deepens your understanding. Now let us study green hydrogen properly. This is a high probability prelims theme because it combines headline importance with process based traps. So hydrogen is often presented as a future fuel, are energy carrier. But not all hydrogen is environmentally equal. That is the most important thing you have to understand. Its classification depends on how it is produced. Green hydrogen generally refers to hydrogen produced using renewable energy pathways, especially through electrolysis of water powered by clean electricity. What is meant by green energy? Green hydrogen energy, green hydrogen generally refers to a hydrogen produced using renewable energy pathways, especially through electrolysis of water powered by clean electricity. Now understand the process. In electrolysis, electrical energy is used to split water into hydrogen and oxygen. This is where electrode logic becomes very important. At the cathode, reduction occurs and hydrogen is produced. At the anode, oxidation occurs and oxygen is produced. Now, this may look like a teeny detail, but teeny details are exactly where UPSC builds traps. A weak student remembers green hydrogen is important. Then a stronger student remembers hydrogen at cathode, oxygen at anode. Green label depends on renewable electricity. That is the difference between topic recognition and process mastery. Another subtle point you have to understand is hydrogen itself is not inherently green. It becomes green because of the production pathway. That means that same final substance can carry different environmental significance depending on how it was produced. Hydrogen itself is not inherently green. It becomes green. Why? Because of the production pathway. That means what? That means the same final substance can carry different environmental significance depending on how it was produced. So the production process pathway is also important here. This is classic UPSC thinking, like same output, different pathway, and a different implication. So UPSC often does not test the headline, it tests the pathway behind the headline. That is most important. So let me take a simple illustration. If someone says hydrogen is clean, so all hydrogen production is green. That sounds smooth, but actually it is wrong. The final output alone does not decide the category. The process decides the category. So hydrogen at anode is wrong answer. All fuel hydrogen automatically green. This is also wrong answer. So you have to alert when these type of statements appear in the examination hall. So now let us move to fusion. What is fusion? Fusion is one of the most captivating energy themes. Why? Because it carries the promise of massive clean energy. But do not approach it like a headline. Approach it like structurally. Fusion means what? Fusion means combining light atomic nuclei to form a heavier nucleus, releasing large amounts of energy. Fusion means what? Combining light atomic nuclei to form a heavier nucleus. Nucleate light atomic nuclei to heavier nucleus through what? And releasing large amounts of energy. This is fundamentally different from fission. Fission breaks, fusion joins. That distinction must be crystal clear. Now, why is fusion so attractive? Because if it can be harnessed reliably, it offers very high energy potential. That is why. So, it also differs from conventional fission in important respects regarding safety architecture and waste profile. That is why. But now comes the hard part is fusion is technically difficult. Why? Because positively charged nuclei repel each other. Okay. To make them fuse, extremely high temperature and pressure conditions are needed. In the other words, the challenge is not simply understanding the scientific principle here. The challenging is sustaining the extreme conditions required here. This is why fusion research is so difficult and so significant. Fusion is not extraordinary because the theory sounds beautiful. It is extraordinary because sustaining star-like conditions on Earth is one of the humanity's hardest engineering challenge. Let me repeat once again. Fusion is not extraordinary because the theory sounds beautiful. Then why it is extraordinary? It is extraordinary because sustaining star-like conditions on Earth is one of the humanity's hardest engineering challenges. Let me illustrate with simple understanding. Join atoms and release energy. Sounds easy in one line, but reality is full of repulsion, instability, containment difficulty, and engineering limits. That is why headlines are never enough for UPSC. That is why headlines are not enough for UPSC. Then now let us handle a very important thing, that is why is fusion often considered safer in one major conceptual sense? Because if the required sustaining conditions fail, the reaction stops. This is crucial. Students often hear the word nuclear and emotionally merge all nuclear technologies together. That is not precise thinking. Fusion and conventional fission different significantly in reaction architecture. Fusion does not continue easily once the extreme sustaining conditions are lost. So compulsory extreme sustaining conditions necessary here. If containment or sustaining conditions fail, the plasma cools and the process shuts down. That is why fusion is often said to have an important intrinsic safety advantage. Conditions, extreme sustaining conditions are important. But here also do not overstate. Do not say fusion is totally risk free. That is careless. The better line here is fusion is fusion has a different safety profile, and one of its conceptual strengths is that uncontrolled continuation is far harder because the reaction stops when sustaining condition collapse. So that is an academically mature statement. So fusion is considered safer not because of its simple, but because failure of control leads to shutdown, not the runway continuation. So let me take a one statement. If a sustaining conditions in a fusion system are lost, the reaction can terminate. The statement is reasonable. Another statement. Once initiated, fusion continues on its own even if conditions fail. Once initiated, fusion continues on its own even if conditions fail. That should immediately look doubtful. Now the notice the pattern emerging. For every serious science and technology topic, UPSC is not asking you to worship the technology. It is asking you to understand the mechanism, the distinction, the trap, and the implications. That is the exact Metis method. Now we come to the system number 4, that is infrastructure. If intelligence shape precision, compute powers capability, energy sustains civilization. Infrastructure determines delivery. This system answers a very important question. What? That is what? How does technological how does technological capability travel? How does a signal move? How does data reach the user? How does network speed improve? How does architecture determine response time and coverage? These are infrastructure questions and they matter deeply because having capability and theory is not enough. It must be deliverable at speed and scale. That is why telecom system matter. That is why network architecture matters. That is why local processing matters. That is why digital infrastructure matters. In the industrial era, roads and ports shaped power. In the digital era, networks and architecture shape power. A capability that cannot be delivered efficiently is not real power. It only stored potential. So how to deliver efficiently? That is the real power. Let me take one illustration. A reservoir may contain water, but if canals are weak, fields remain. Likewise, digital capacity without infrastructure remains underused. This should feel foundational, not technical. Now let us understand the logic behind advanced communication systems like 6G. Many students reduce this topic to a slogan. Higher generation means faster internet. That is too shallow. The deeper understanding begins with frequency and a trade-off. As communication systems move to higher frequency bands, they can potentially support higher data rates and lower latency. That is the attraction. But technological gains never come free of cost. Higher frequency often also means lower range and greater sensitivity to blockage or penetration challenges. This is the physics trade off students must remember. So, the correct understanding is not 6G is simply better. The correct understanding is what? 6G, like higher frequency communication, may offer major performance gains, but at the same time, but Those gains come with infrastructure and propagation challenges also. This is the correct and real understanding. And that is how UPSC thinks. It allows principle to implication logic. Technology does not operate through miracles. It operates through trade-offs. So let me illustrate simply. A very sharp, fast-moving signal may give greater performance, but not necessarily easier long distance or obstacle penetrating coverage. This is the intuition you must hold. In the UPSC may trap like this. Do not assume higher generation always means easier reach. These types of traps you have to always alert in the examination. That is the thing. Higher speeds may lead to lower reach also. So now let us convert that principle into real world infrastructure logic. If higher frequency signals face more blockage and range limits, then broad area coverage becomes harder. So what happens? You need denser infrastructure. You need more local nodes. You need more small cells. Instead of depending only on a few large towers, the architecture becomes much more granular. This is a beautiful UPSC zone because one scientific property produces one infrastructure implication, and that is exactly the kind of relationship the examiner likes. A student who only memorizes 6G is fast has not completed learning. Then what he will do? That what he has to do is a serious student asks what will this require on the ground, what deployment pattern follows, why is dense architecture needed. This is the better level of preparation for UPSC serious candidate. Future connectivity will not simply be faster, it will also be denser, more local, and more infrastructure intensive. So let me take one illustration with the two statements. Statement number one is higher frequency systems can support high data rates. Statement number two, therefore they typically require less dense supporting infrastructure. This is exactly the type of trap where the second statement sounds efficient but may be wrong. So you have to be careful with the traps. Always UPSC make ready for you. Now let us understand two final infrastructure themes, that is Web3 and edge computing. These are not identical topics but they share a structural idea. Both point at different ways toward reducing heavy central concentration in certain digital functions. First of all, we have to learn about Web3. At a broad level, Web3 is associated with more distributed digital architectures, especially in how participation, validation, or ownership may be structured relative to centralized platform models. Let me repeat again Web3. At a broad level, Web3 is associated with more distributed digital architectures, especially in how participation, how validation or ownership may be structured relative to centralized platform models. Now be careful. Do not romanticize every new buzzword. A serious student never assumes that new equals superior. But conceptually, Web3 signals movement toward distributed control structures. Second one is edge computing. This is simpler. Instead of sending all data to a distant central cloud for processing, some process some processing happens closer to where the data is generated. So why is that useful? Because it can reduce latency, it can improve response time, it can help in real time scenarios, it can reduce pressures on distant central systems for certain tasks. Now what is the common theme here? Control and function are shifting closer to the user, device, or source point. That is the big pattern here. The next digital phase is not only about bigger centers, it is also about smarter distribution. Let me take a simple illustration. Not every village problem should travel all the way to Delhi before being handled. Some problems are better served closer to the source. That is the intuitive logic behind edge thinking. So now we become to biological person. Like now we come to the final system, that is biology. And this is perhaps the most sensitive system of all. Why? Because now technology is no longer only influencing information, machines, energy, or networks. Now it is entering life itself. Once science gains the power to observe, edit, modify, or redesign biological systems, the stakes become enormous. Now, these questions are not just scientific, they become ethical, medical, legal, intergenerational, and civilizational. That is why biology related technologies are so important for UPSC. But students often mishandle this area. One group stays at buzzword level. Another group gets lost in technical details. The correct path is balance. Understand the mechanism, the distinction, the implication, the ethical concern, and finally the trap. That is the UPSC way. When technology enters biology, it enters the question of how far human control should be allowed to go. In a biology, a technical distinction often becomes an ethical distinction. Remember that line very carefully. Now let us take the flagship example to understand easily, that is CRISPR. CRISPR is a gene editing tool. That is the basic description. But for UPSC, basics are never enough. So let us deepen the structure. First distinction, editing is not creating. CRISPR allows targeted modifications in existing genetic sequence. That is editing. Loose language like CRISPR creates a life is inaccurate and unsafe. The second distinction is somatic versus germline. Somatic editing affects the body cells of an individual. Its effects remain limited to that individual. Germline editing concerns changes that can affect future generations through inheritance also. Now, what the difference is ethically enormous. Why? Because a change affecting one present patient is one kind of intervention. It is okay. A change that may pass into future generations is another kind of entirely another kind. Now questions multiply. Who concerns the future generations? What if unintended effects appear later? Could such technologies deepen social inequality? Could they be misused? Where should regulation stop? This is why CRISPR is not just a biotech story. It is a governance story, an ethics story, a civilization story. And that is exactly why UPSC is interested in it. So CRISPR is not only about what we can edit or not. It is about what we should be allowed to edit. Let me give some illustration to easily understand. Giving a medicine to one patient is one level of intervention. Changing an inheritable biological line is another level of intervention entirely. That is why germline editing carries such deeper ethical intensity. UPSC may trap like this. A statement casually treating somatic and germline editing as equivalent should immediately raise suspicion. So germline and somatic is not the same. So you have to be careful here. We have to raise suspicion. Now let us step back and integrate everything. Today we did not study science and technology as random current affairs. We studied it as five systems of control. That is system number one, intelligence, control over perception. Then we move to system number two, compute. That is control over computational capacity. Then we move to system number three, that is energy. Energy means what? Control over industrial force. Then we move to again infrastructure. System number four. Control system number four, infrastructure. Control over transmission and delivery. And the final system, biology. Control over life processes. Now look at what this framework does. It replaces what? Chaos with structure. Once a structure enters the mind, memory improves. Once memory improves, recall improves. Once recall improves, elimination improves. Once elimination improves, the exam hall becomes calmer. And that is the whole point. UPSC is not defeated by reading more and more scattered material. It is defeated by a structured clarity. That is the Metis way. We are not here to overwhelm students with information. We are here to remove confusion from students. We are not here to sound technical. We are here to think technically. We are not here to glorify content volume. We are here to build exam precision. UPSC does not reward the student who has seen the most scientific terms. It rewards the student who can decode the system, detect the trap, and remain precise under pressure. So, what should you now do for Prelims 2026? Is very simple. Stop reading science and technology as disconnected updates. Start building systems. Start building system nodes. Create five headings: intelligence, compute, energy, infrastructure, and biology. Now, under every topic you study, write four things. First one is what is it? Number 2, how does it work? Number 3, what is the UPSC trap? And number 4, why does UPSC care? If you do only this consistently, your science and technology preparation will become sharper than most aspirants. Because now you are not collecting noise, you are building a thinking system. That is what serious preparations look like. That is how you reduce confusion. That is how you increase precision. That is how you protect marks. Do not prepare more and more information. Prepare better and better structure. If this masterclass helped you see science and technology differently, then do not stop here. Rewatch it systems wise. Make your own 5 system notes. And from now on, wherever, whenever you read any science and technology topic, never ask only what is this. Also ask what system does this belong to? What trap can UPSC create from this? That is when real preparation begins.